Hi Trigoners, so this is Notes 3.1, Day 2. Our objectives are to be able to understand function notation and to be able to evaluate functions from graphs, function notation tables, and piecewise defined functions. So we're going to start off by taking a look at this graph, and I might ask this question. Find the value of y when x equals 0. So I'm going to ask you to go ahead and answer that question, number 1, and go ahead and pause the video and give it a try. Okay, so hopefully you're thinking, if x is 0 for this particular function right here, you would have y equals 2. But if x were 0 for this particular function, you'd have y equals 3. So the question is, which function are you referring to? So the question's ambiguous because I might ask you, which function are you talking about? So why do we use the function notation? Many reasons. There are many reasons that we will study, but for right now, one reason is it allows you to call the different functions different names. Like you could say one is f of x, one is g of x, etc. Okay, so that's helpful. Like you might say this one is f of x, and you might say the other one is g of x or h of x or something like that. Okay, so let's go ahead and move on to the next question here. So it says, f of x implies the relations of function. We've been talking a lot about functions past the vertical line test. For every x, there's a unique y. So this statement, if I say f of 0 equals 2, that indicates in a very concise way that the ordered pair 0, 2 belongs to the function f. So f of x is the value of the function f at x, and x, f of x belongs to the function f. So in other words, we have our x and our f of x. And that implies x, y values where the ordered pair is on the function f. Okay, so let's talk about other letters. You can use other letters other than f and x because, again, the f is referring to a function and the x is referring to the independent variable. But notice I could say g of t. So go ahead and pause the video and substitute -2 in everywhere you see a t in the function g. Okay, so come on back. Did you notice that we have 4 minus 3? So g of -2 is 1. So this is saying that there's an ordered pair at -2, 1, and that -2, 1 belongs to the function g. Okay, let's go ahead and go to the next page. So now we're going to talk about evaluating functions from graphs. So we have two graphs here. One is the function f of x. One is the function g of x. And again, let's first check. Go ahead and check, is f of x a function, is g of x a function? Because again, this notation implies that it must be a function. So go ahead and think about that. Okay, so did you say that yes, they are functions? There's a unique y value for every x, passes the vertical line test. So let's go ahead and answer the first few questions, g of 0, g of -3, etc. Notice that if I want g of 0, I have to look at the function g, and I'm saying when x is 0, what is y? Okay, so notice when x is 0, this is an open circle. There's no point there, but here there's a point. So when x is 0, the y is -4. Go ahead and try and finish the next few questions here, g of -3 and f of 4. Pause the video and give it a try. Okay, so again, we're on the g function. So if I put -3 in for x, that's over here. So the y value is 0. And f of 4, let's do a different color here. So now, notice if I want to look at the function f, and I'm saying when x is 4, what is y? So again, this is an open circle, so the y value is 0. Now, for the next couple questions, notice I have f of g of 0 and g of f of 1. So this has an extra step here. So first of all, I have to find g of 0. Well, we know that g of 0 is -4. We found that over here. So we have f of -4 because again, if g of 0 is negative 4, you can substitute negative 4 in for g of 0. Now I'm looking at the function f of x over here, and I notice that when x is negative 4, y is 0. Go ahead and pause the video and try g of f of 1. Okay, let's see how you did. So first of all, if we look at the function f of x, when x is 1, y is 2. So f of 1 is 2. So now I can say, substitute 2 in for f of 1. So now I want to find when x is 2 on the g of x function. So when x is 2, that's right here, notice that there is no point there. So that is undefined. Okay, so for the next part, we are going to, oh, I'm sorry, we skipped one. It says find x when g of x equals 0. So go ahead and pause the video and think about how you would answer that question. Okay, so let's see what you decide. So when we decided when g of x is 0, so that's like saying the y coordinate, the output. So the y on the function g is right here when y is 0. So notice I have y is 0 at negative 3 and at positive 3. But notice that there's an open circle here, so that's why 0 is not an answer. Okay, great job, everybody. Let's go ahead and look at the next part. For part 3, it says evaluate functions written in function notation. So let's take a look at that first one. This is saying when x is 3, what is y on the function f? So we're going to substitute a 3 in for x. And you should get negative 2. So why don't you go ahead and try B, C, and D and see what you get. Okay, come on back. So notice for G, this time, we're going to put negative 1 in for x. And you should end up with 0. Okay, let's go ahead and write this over here. First, G of h, you're going to substitute an h in for x. There you go. So your answer has an h in it. For part D, I need the function f, but again, I'm going to replace the x with 3 plus h. So I'll put parentheses around my 3 plus h. And I end up with negative 2h minus 2. Okay, so what I would like you to do next is go ahead and give it a try. Try E, F, and G. Pause the video and see if you can make those, evaluate those functions. Okay, so let's try, come on back, let's try E. So notice for E, they want us to do f of 3 plus f of h. We already found f of 3 is negative 2. And we've f of h, you're going to substitute h in for x. So I took f of x, and everywhere I saw an x, I replaced it with h. So now I have some like terms. Negative 2h plus 2 is your answer. Okay, let's try f. It might help if you find g of 0 first. If you put 0 in for x, you end up with 0 squared minus 1. So g of 0 is negative 1. So now if I want to find f of g of 0, I can substitute negative 1 for g of 0. So now I'm looking at the x equation. Everywhere I see an x, I replace it with negative 1. And you should get 6. Okay, so go ahead and pause the video and check your work for g. Okay, so for this one, I wanted g of f of 0. So it would help if we knew what f of 0 is. So everywhere I see an x in f of x, I'm going to replace that with 0. And I get 4. So if I wanted g of f of 0, I can replace f of 0 with 4. So here we go. I take my x squared minus 1, and instead of x, I'll put a 4 in there, and I get 15. Okay, so we have a table on the next page. So go ahead and take a look at the table and see if you can answer the questions. We're going to evaluate functions from a table. Go ahead and pause the video and see if you can answer A, B, C, and D for number 5. Okay, let's see how you did. So for the first question, notice I'm asking you for f of 0. So really, you don't even need g of x at all. So this says when x is 0, what is f of 0? So when x is 0, the input is 0, what is the output, or what is f of x on the function f? What is the y-coordinate? So notice we have when x is 0, the y-coordinate is 3 on f of x. Okay, so now for the next one, I'll erase that. For the next one, let's get a different color. We're talking about the function g. So really, f, we don't even need that at all. So this is saying when x is -1, what is the y on the g, on g of x? So let's take a look. If x is -1, the y value is -2. Okay, so let's take a look at the next question. It's saying, what's f of 0 plus g of -1? Well, they want us to add that together. Okay, so this last one might be the trickiest. Okay, so let's erase this. So for the first part, a different color. Oops. Okay, so for the first part, they asked us for g of 3. So let's find that. That's on the inside here. Let's find that first. So I go to, when x is 3, what is the y-coordinate on g? So the g of 3 is 2. So now if I want f of g of 3, I can replace g of 3 with 2. So now I don't want g anymore. I'm saying when x is 2, erase this over here. When x is 2, what is y on f? So that would be 4. Okay, so hopefully we understand about how to think about functions and function notation with tables and equations. But now we're going to look at something called a piecewise defined function. So a piecewise defined function, those are functions with definitions that involve more than one expression. So for number 6, notice I'm telling you that f of x is radical x for values of x greater than or equal to 0, but f of x is x plus 1 for values of x less than 0. Now later on we are going to sketch graphs of this, and I think this would be a much easier question if you had the graph. But for now, why don't we try and do this without a graph? So if I said f of 0, I'm saying x is 0, what is y on the function f? So notice this is the expression that we're using for x greater than or equal to 0. So I would have to say if x is greater than or equal to 0, that means that f of x equals radical x. So you would have to say square root of 0, which is 0. But what if I asked you for f of 4? That's saying if x is 4, what is y on f? So if x is 4, I'm still using radical x, so you would say radical 4, which is 2. Now for this next question, I'm saying f of -2. Well, -2, -2 is less than 0, so I would use x plus 1. Why don't you go ahead and give numbers 7 and 8 a try. Go ahead and pause the video and give it a try. Okay, so let's see how you did. So first of all, for number 6, I did show you what that graph would look like, but we're going to work on graphing these another time. So for this first one, I'm saying when x is 0, what is y? And notice we have x greater than 0 and x less than 0. So that point is undefined. But for -1, I would want to look here. So I would say -1 squared, but the opposite of -1 squared, that would be -1. And then over here, that was the answer. I'm saying when x is 1, what is y? So you would have to use this part, and that would be 1 squared, which is 1. Okay, so go ahead and give the last part a try. I will fill in the answers for you. And give it a try on your own.